Hi everyone, and welcome to our next set of lessons where we are going to have a look at our exponential function. Now our exponential function's equation looks like this or this. Now what does these letters actually mean? Well, this a represents the coefficient that is in front of the base. Now remember, a base is a value that contains the exponent, and in an exponential function that exponent is an x. And then we have plus q, and this q represents the asymptote. So in other words, an exponential function also has an asymptote, and that is a straight line that the function can never cross. It also indicates whether the graph moved up or down. Okay, got it? Now the only difference between this equation and this one is in the exponent we've got x plus p, and this plus p represents left or right movement. So for example, if this was x plus 3, we move 3 units to the left, and if it was x minus 2, we move 2 units to the right. Now let's go and look at the further meaning of these letters. Now let's start with our plus q. Now that is our asymptote. So let's go draw it in. So I'm going to draw in our asymptote, and we know that our horizontal straight line is always y is equal to, and in this case it's q, so I'm just going to write y is equal to q. So if q was a plus 3, we're going to write here y is equal to 3. Got it? Now, why do we draw the asymptote first? Because now we can go to our coefficient, which is this a value, and we can quickly see whether we should draw the exponential function above or below the asymptote. Now, when do we write it above? Well, when a is a positive value. So if a is greater than 0, we draw our exponential function above the asymptote. That's our first step. Now we know we are working above the asymptote. Then we go to our base. That is the value that contains the exponent. If this base is a value greater than 1, for example 2, 3, 4, 5, 6 and so on, well, we know that we can draw our exponential function from left to right away from the asymptote. Got it? So if b is greater than 1, we draw our function away from the asymptote. Okay, excellent. So if a is greater than 0, it's a positive value, this coefficient is positive, we draw our function above the asymptote. But if this base is a fraction, a value between 0 and 1, we are going to draw our exponential function from left to right towards our asymptote. Got it? Excellent. Now, what if a is less than 0? So if this a, the coefficient, is a negative value, if a is less than 0, we know we're going to draw our exponential function below the asymptote. But now we still go to our base, and if our base is greater than 1, well, that means from left to right, we draw it away from the asymptote. So always, if b is greater than 1, b is greater than 1, doesn't matter if we draw it above or below the asymptote, we draw it from left to right, away from the asymptote. Got it? And then, if a is less than 0, we draw our exponential function below the asymptote. But if b is a fraction between 0 and 1, we draw it towards the asymptote from left to right. Same as if we were drawing the exponential function above the asymptote, because a was a positive value. Look very closely. If b was also a fraction between 0 and 1, from left to right towards the asymptote. From left to right towards the asymptote. Got it? So that's the meaning of our coefficient and our base and our asymptote. Let's go and draw a real example. Now in the following example, we are given fx is equal to, in brackets a half, to the power of x plus 3 minus 1. We know that this is an exponential function because x is in the exponent, and we want to draw this function. So here is our y-axis and our x-axis. So let's start by drawing in our asymptote. Now our asymptote should be at minus 1, so we're going to draw in our horizontal asymptote so that it goes through our y-axis at minus 1, and we can put in the coordinates 0 and minus 1. I always like to write the equation of our asymptote as well, so it will be y is equal to the place where it goes through the y-axis, which is -1. And there is our horizontal asymptote. Now we can kind of get an idea of what our exponential function should look like by going to our a value. Now we don't see a value there, but it doesn't mean it doesn't exist. Our a is a positive 1. Now when a is greater than 0, or when it is a positive value, we know that we are going to draw our exponential function above the asymptote. So it's going to be above the asymptote. Then we go to our b value, which is the base of our exponent. So this is a half. And this base is a value between 0 and 1. It's a fraction. So we are going to draw our exponential function from left to right towards our asymptote. Now that gives us a very good idea of what it should look like, and as I draw this in my mind, I know we're going to have an x-intercept and a y-intercept. So how do we calculate the y-intercept of any function? Well, we make the x a 0 because the x coordinate on the y-axis is always 0. So y is equal to, in brackets, a half, and in the place of x we put a 0 plus 3 minus 1. And if I do this calculation, we're going to have y is equal to minus 0,875. Now I'm going to leave it as 3 decimals, and then I'm going to go plot that point on my y-axis. So it will be somewhere over here because it's a negative value. So there it is, and we can put in the coordinates as 0 and minus 0,875. Now we have to calculate our x-intercept. Now how do we calculate the x-intercept of any function? We make our y-coordinate a 0, and fx is y, so in the place of y we're going to put a 0 is equal to, in brackets, a half to the power of x plus 3 minus 1, and now we want to solve for x. Now x is an exponent, so we want to get the bases on both sides to be the same. So here we go. Our first step is to take this constant to the other side. It becomes a plus 1, and there it is, and equal to. And then I'm going to rewrite this half so that it becomes 2 to the power of minus 1. I'm going to take this denominator and put it above the line, and its exponent will become a negative. That's part of the laws of exponents. So I'm going to have, in brackets, 2 to the power of minus 1, and we still have the exponent on the outside, x plus 3. And then another law of exponents, I'm going to take this exponent on the inside and multiply it with both, just like the distributive law, with both of these values on the outside. So now we're going to have 1 is equal to 2, and minus 1 times the x is minus 1x, and minus 1 times the positive 3 is a minus 3. Now, so far so good, but we can't go any further than this. So what we want to do is we want to get the bases to be the same. Now, how can I make a 1 so that it looks like a 2? Well, I can write 2 to the power of 0, because any base to the power of 0 is 1. So there we go. So 2 to the power of 0 is equal to 2 to the power of minus x minus 3. The bases are the same, so I can simply cross them out so that only the exponents remain and calculate x. So now we have 0 is equal to minus x minus 3. We take this constant to the other side, becomes a plus 3 is equal to minus x. We divide with the coefficient, which is a minus 1, and 3 divided by minus 1 is minus 3 is equal to x. So our x-intercept is at minus 3. So that will be over here, and I plot the point. I put in the coordinates, minus 3 and 0. And as we know, now we can connect these points, and our exponential function from left to right goes towards our asymptote. And there it is. So, just like we said, that's the way it should look like, and there it is. See you again next time. Bye.